We're going to use our new definitions of similar triangle similarity in proofs today. First proof, given DE is to GH, DF is to GI, and EF is to HI, prove that angle E is congruent to angle H. What does it mean if you have a side of one triangle proportional to a side of another, and the third side is proportional? That would mean that triangle DEF would be similar to this triangle on the right. We just have to make sure we line it up correct. Once we say these two triangles are similar, we can prove that angle E is congruent to angle H by corresponding sides congruent. So let's make a setup. We have a statement over here and a reason over here. So the given is the first step always. I'm just going to put a dot, dot, dot here. You should fill it in, and that is given. So the second step would be we can show right away that these two triangles are similar by what reason? Side, side, side similarity. Now the trick is though, we have to match up DEF correctly. Okay, so DE is to GH, so GH would have to live here, and then of course the leftover would be I, and I always like to just double check. Okay, so DF, which is the first and third position, should match up with GI, which it does. Let's check EF while we're here. EF is the second and third position, and HI is the second and third. So that's just a way for you to double check that you line everything up correctly. Once we show these two triangles are similar, which we need to do right here, then we can say that angle E equals angle H by corresponding angles congruent, which is one of the definitions of similarity. Okay, number two. Let's see. We're given that HK is perpendicular to GH. So we'll put the perpendicular. Don't forget to mark up the diagram. KF is perpendicular to GF. And our goal is to prove that HK times GO is congruent to FG times KO. Well, I'm not sure what to do, but I wonder if we can show, since of course this is a similarity unit, can we show that these two triangles are similar? And maybe we can play around with their sides. This is side information, so the strategy would be to first prove that the triangles are similar, and then maybe set up some proportionality. So maybe step one is to prove that the triangles are similar, and step two would be to show that the sides are proportional, and maybe we can use some of our properties of proportionality to maybe cross multiply, something like that. Okay, so let's set up a statement reason table, and I think I can see right now we have an angle and an angle, and the two angles are congruent, and I think we can, well, you guys I'm sure have seen that these two angles are vertical, which are congruent, so we can show they're similar by angle-angle similarity. So let's write down HK is perpendicular to GH, KF is perpendicular to GF by given. And we can combine a statement here if we, well, let's just break it down. Angle H equals 90. Angle F equals 90. Definition perpendicular. We haven't done proofs for a while, so we don't need to combine steps right away, which means angle H equals angle F. By what reason? Substitution. And I might call this angle 1 and call this angle 2 just for convenience in the diagram. So angle 1 is congruent to angle 2 by vertical angles congruent. And now we can show that these two triangles are similar by angle-angle similarity. So let's mark it up right. Doesn't matter. Let's start with HOK, I guess. Triangle HOK. And we have to make sure we match angle H up with angle F, angle O up with angle O, and angle G up with angle K. HOK, FOG, fog. Okay. So now, why don't we set up some proportionality, maybe using what we have here. Like I see an HK here and a KO and a GO and an FG. So let's see what happens if we match up HK to FG. Because I see HK is here and I see FG is here. And then maybe I match that up with an, what else are we given? Oh, KO, which is the same as OK, right? Just the other way around. KO and GO. Corresponding sides proportional. So we can just cross multiply to get our answer. And so HK times GO is equal to FG times KO. Cross multiply. So we have finished that proof nicely. Let's go to the next one. Given EF is parallel to RS. Oh, it's similar to the last one. So again, if we can show these two triangles are similar, we can maybe set up some sides being proportional and cross multiply. So I think I will start this for you and you can finish it. EF to RS given. And again, maybe it's easier to put like a little angle 1 and angle 2 here. Well, we know that angle X is congruent to angle X by reflexive. So now we have one angle in the little triangle congruent to one angle in the big triangle, and angle 1 equals angle 2 because what is it? Corresponding angles congruent if lines are parallel. So we can say that triangle XEF is similar to triangle XRS by angle-angle similarity. And again, we set up the proportions. Well, FX first and third is to SX as EF second and third is to RS. Corresponding sides proportional if triangles are similar. And the last step would be the cross multiplication. Excellent. All right, let's set up let's talk through example 4. I think you guys probably are ready to do some on your own. Given angle 1 equals angle 2, first step is to show that this little triangle is similar to AED, which is the big triangle. And then once we show they're similar, show that AB is to AE as BC is to DE. Now that's pretty straightforward because that's just corresponding sides are proportional. Okay, so we have angle A and angle 2. Do you see another angle that's congruent to each other in the little one and the big one? Angle A. So by reflexive, we would say that angle A equals angle A, and then we could show those two triangles are similar. Angle A is congruent to angle A by reflexive. So again, we have to be careful. So we have triangle ABC similar to triangle A, and B has to match up with angle E. So it would be angle AED. Great, we did this first one by angle similarity. And the next step is simply that AB is to AE, corresponding sides are proportional, as BC is to ED. So the next page has 6 proofs. Take your time, mark them up. We will go over these in class tomorrow.